So now in this example, we're given a function and we're going to analyze it to find all intervals of increase, decrease, concavity, and inflection points. So if we're trying to find where the function is increasing or decreasing, the first thing we should find is the derivative. So I have a high and I have a low, so I'm going to do quotient rule. So that's low, d high, minus high, d low, square the bottom, and away we go. So now if I simplify my numerator, f prime of x becomes negative x squared plus 2 over the quantity x squared plus 2 squared. So now that I have my derivative, I need to find my critical values. So we see that this denominator here will never equal 0. So there's no critical values for the denominator, but I know f prime of x equals 0 when x squared equals 2 or x equals plus or minus square root 2. So those are our two critical values. So now I can use a number line to do a sign check on my derivative to see where it's positive or negative. So now I'm comparing my derivative to my original function. So if I plug in 0, for instance, oh yeah, and the denominator is also always positive. So when I'm checking my sign, I really only need to plug into my numerator. So if I make x equal to 0, here in the middle piece, I have a positive number, so it's increasing. Square root of 2 is less than, let's say, 4. So let's say x equals 4 and x equals negative 4 is what we can check. You can pick any number. So negative 4 squared plus 2 is going to be a negative, so that's decreasing. Negative 4 squared plus 2 is also a negative, so that's decreasing. So to answer part A and B, A, f is increasing on the interval negative square root 2 to square root 2 because f prime of x is greater than 0 on that interval. So notice this is justifying my reasoning right here. I justified my reasoning because my second derivative is greater than 0. I misspoke. My first derivative is greater than 0. So f is decreasing on negative infinity to negative square root 2 union square root 2 to infinity. And let's justify our reasoning because f prime of x is less than 0 on those intervals. So whenever we're looking for increasing or decreasing, we're focusing on the first derivative.